We are live. So, hello everyone, and welcome to another session of Testmu 2024. I hope everyone is so far enjoying the sessions aligned for you guys. I'm Kavita Joshi, and I'll be your host for this session. Today, we'll deep dive into the good and bad of contract testing. Today, we have with us Wessel Braakman. He's an expert in the field of test automation, having more than 10 years of experience in the industry. Throughout his career, he has held a variety of roles. He has worked as a tester, scrum master, business analyst, and also as Mendix developer. So, before we start the session, let me just tell you a few housekeeping items. There is a chat box on the right. You can go and add your queries there. And if time permits, we'll take up the questions at the end. Also, all these sessions are being recorded and they'll be available in the Lambda Test YouTube channel. So, if in any case you miss any of the sessions, you can go back and check there. So, with said that, thank you so much, Wessel, for joining us. The floor is yours.
Thanks. Thank you all for having me. Let's dive straight into it. I'm just going to share my screen. There it is. Give me a minute. Share. Is it sharing?
Yes, your screen is visible.
Perfect. First of all, thanks so much, Lambda Test, for having me here. I hope everyone learned something of it. And yeah, let's start with the presentation. First, going to quickly say a few words about myself. Then I'll get into what a contract is and why we want to do contract testing. I'll go to a couple of, actually a few of the implementations of contract testing and end with a recap and a conclusion. So first about me, as already stated, my name is Wessel Braakman, do testing, test automation, have done Mendix development and have been a Scrum Master in the past. Lived in the Netherlands, where I was born, but moved to Norway with my family in January of last year, where I started at the magnificent company of Bouvet. And my current role is tester and test automation at Statnett, which is the state-owned power grid operator of Norway. I snuck in an extra chapter, 2 slides about what an API is before we start about the contracts. In the IT industry, as many of you well know, a lot of different systems have to work together and talk together, communicate together. And one way of communicating between 2 systems is an API. This means that a consumer of data can send requests to a producer. This can be to get information, to post something new, to patch or delete something, etc. And the producer, in most cases, when everything is operational, sends a nice response with whatever the consumer needs. In contract testing, a lot of different tools can be used for CI/CD integration, for manual testing, whatever. I named a couple of here on this slide, but in this presentation, I will be using PowerPoint for the presentation, and I will be using Postman to do some quick demonstrations about the different contract testing types. Also in this presentation, I added the disclaimer that this was AI generated, which was quite obvious, but we are talking about a bookstore. So that's a store that contains a lot of books, and this bookstore wants a third party to develop an app for the phone in which people can see which books are available in the bookstore. So keep in mind, it will be a recurring theme during this presentation. We'll talk about a bookstore and the bookstore app, and the app will show books available in the bookstore. Continuing with what a contract is. As I said, there are producers and consumers of data. And in our bookstore example, the bookstore is the party that produces data about books because they have the books. And the consumer is the app which wants to show the books. So in our example, the consumer sends a get books request over an API to the producer, and the producer in return responds with a list of available books. Very simple example, but I hope it works for you guys. Because the producer and consumer of data have to talk together, the one requests something, the other delivers something, we can define what they request and what the response looks like in a contract. And this contract can be one of two things. It can be either structural and it can be behavioral. And of both of those, there can be multiple for one API. First, looking at a structural contract. A structural contract ensures the data structure matches the expected format. So we look mostly at field names, data types, required or optional fields, such things. Maybe some of you are familiar with it, but a common way of documenting this is OpenAPI or Swagger documentation, where the teams can work together to create a description of the structure of the API. And this in return also can be seen as a kind of contract, because if everyone agrees on this, then the structure defined in OpenAPI is leading for the API development. The other type, behavioral contract, is more about how the API behaves. So we're not just looking at whether we get a string value or an integer back from the API, but we look at specific scenarios with specific business behavior behind it. So if we say that our given is that this books endpoint is operational and functioning, when the user sends a GET request to books, then the API returns with the 200 status code, which means everything went well, and the response body contains a list of books. So this is not a very tight contract, but this at least says that when the user requests a list of books should be returned. These behavioral contracts can be defined in Excel, Wiki, Confluence, whatever. And if tools are implemented to work with these kind of contracts automatically, like Pact, then one can also write a contract in Pact. And this does not go with the given when then per se, but we do see that we have a provider state. The book exists for the publisher. That could be a given. And then we see the request. We get books with an actual query parameter, and we see a response would be the then it responds a list of books. So two different ways of defining a contract like this. More about that afterwards. Let's first get into why we want to do contract testing. Again, producer, consumer, there's one line. One wants to get the list of books and the other has to deliver the list of books. Now, in the old software development lifecycle, where we plan, design, develop, deploy, and do maintenance afterwards, the test phase was a really big one. This means that in this test phase, everyone would deliver whatever they had produced and were finished with on an integration test environment. And then we would do the integration testing, which is a very late stage of doing things in. With contract testing, we can already start some of the testing and some of the defining and collaboration in an earlier stage by defining this contract and talking about it. So we can start thinking about it in a requirement stage. We can keep thinking about it and talking about it in the design phase. Then while developing, we have this contract available that we should adhere to. And then in the end, we have to test it when everyone's done, but we already covered so much in the stages before this. So it's actually a shift left way of thinking. We start with API design, development, collaboration in a very early stage and not in the test phase. One thing that I personally also really like about contract testing, and this is not about pointing fingers, but say the get books response fails for whatever reason. In the past, it will be really difficult to decide whether the producer or the consumer did something wrong in a way or did a breaking change, because everyone could interpret what the other said or emailed in a different way. But by having a really strict contract and something that's really well defined and talked about, it's really easy, in this case, for example, to see that the producer introduced a bug or breaking change into the API. And that really helps speeding up the process in the end. Okay, into the first type of contract testing, schema validation. In schema validation, we actually test our response or our request against the contract. We just talked about the types of contracts. So we do not need this integration environment, but we just check whether what is sent to the producer or comes from the producer adheres to a certain contract. Schema validation is always a structural contract, which means that we look at field names, data types, and required or optional fields. So for example, we talked about this books API that returns a list of books. This is a schema that I will actually show you in my example after this works for Postman. It is a JSON schema where I say that the return type should be an array. You can read the comments over there on the right. Each item within this array is an object, and it contains a couple of properties: book ID, title, author, description, genre, and score. And lastly, we define that book ID, title, and score should always be returned. Now, there's a tiny icon on the bottom right of this slide, which means we hop to Postman and see a bit what this looks like. So we have this books API, and first we'll do is send a request. And then we see in the response that we indeed get an array, so a list of objects, and all these objects contain the items that we just talked about. But we want to make sure that they always do this. So I want to write a test. And the first thing I want to do is define the schema. I just saw it in my presentation, but I just copy-pasted the exact same thing that was in my presentation. So I'm going to check that I get back an array with objects containing all these elements, and required are these three. Now, my test may seem technical for some, but I use a JSON validator. And AGV literally stands for another JSON validator, which works with JavaScript. So it works with Postman. I say that I want to retrieve the schema that I just created in the pre-request script, and I want to validate my response against the schema. So this is the actual test, and I won't go too much into it, but what I do is I get a response body, like the one over here, and I expect it to match the schema that we just defined. So if I click this, then obviously because I created it and know what happens, the result is a pass because it matches the schema. But I also want to show you what happens if, for example, the publisher, the producer of data, wants to do something else. So for example, we have a title, author, description, but the ID is called book ID. We all know it's about books. So what if they introduce just ID instead of book ID? So if the producer does this, and we click the send button again for our test, now we see that we get ID back in our response instead of book ID. We also see that our test has failed, our schema validation. Now I have to get into the console quickly to show you why it failed. And there we have it. It should have the required property book ID because that's what we decided we should always get back in our contract. So in this case, the producer had a great idea of changing book ID to ID, but it introduced a breaking change at the consumer side. But we found it because we did this simple schema validation. So schema validation is something that I often implement right away when dealing with APIs, especially complex APIs, not only because I want to make sure that I always get the same thing back, but also because I have to dive into the documentation, which often is very limited, which also can help me trigger the developers to update the documentation with what is actually the current state of the API. Back to the presentation, hopefully. Let's see if I thought I saw it open somewhere. Excuse me, there we go. Back to the presentation. So we just saw an example about schema validation and how we can really quickly see a breaking change. So the pros, it ensures data structure. We just saw, we check the types that come back, we check if all the required items come back, etc. It's really simple to implement. All you have to do is either create a schema or get one through, for example, Swagger or OpenAPI. You get really fast feedback because it's a static analysis of the response. There are JSON validators for pretty much every language available, and they're automatable in CI/CD. If you use Postman, you simply do it via Newman, which is the command line interface of Postman. The bad. It's not necessarily bad, it's just limited. So there's no content validation. If I get an author back, it could say anything within that string. It doesn't have to be a real name, and that's something that we cannot check with schema validation unless we use, for example, really complex wildcards. There's no behavioral coverage. We just check the response and then we get the right things back. We don't check anything about, for example, sorting of books based on an ID. And there's no assurance of backwards compatibility. So if a breaking change is introduced or some updates are introduced, it doesn't inherently check backward compatibility across different versions of the same API. Moving on to the next. Sorry if I move a bit fast, but I have a lot to say, little time to do it in. Producer-driven contract testing. We have, again, this bookstore that wants to send books to the consumer. But in this case, there's not a shared schema based on solely structure, but it's the producer that defines a contract and then checks with the consumer whether or not that's okay for them to receive. Thing is also, if there's multiple consumers, they all have to adhere to the same contract provided by the producer, or the producer has to abide by the same contract and all those consumers have to consume it that way. Just talked about these. It can be structural contracts, so it can be another schema validation because all those consumers need to know in what way and what format they receive the data. But these can also include behavioral contracts. So I just had an example. We show the initial context. There's an action or trigger, and we have an expected outcome. In this case, for example, if they want to add publisher information, then they can say, given the books contain information about their publisher, when a list is requested, then the response contains a publisher field. That's something that wasn't there before. So I see this icon again in my bottom right. So we move back to Postman. So moving to the PDC. First of all, we have the same JSON validation that we had before. So I mean the same schema validation as we had before. So if I click the send button now, I expect the test to pass because we have the book ID, title, etc. That hasn't changed. But like we said, in this case, the producer wants to add a publisher parameter to the response. Well, if you take a good look at the schema, then we see that there are no publisher elements yet. And there's no publisher element required. So adding something looks like it would not break the current config or the current contract. So let's see if that's true. We go to the publisher test. So here we start again with the same schema validation that we did before. But now we added a test where we defined publishers, expected publishers for each book. And then we check for each book whether the publisher based on book ID is correct for each book. So again, not going to technical, but we're just going to check whether or not this passes. And let me see. So this is the original one. So now it fails because we don't have the publisher yet. And now if they update it with a publisher element, and I wait a bit until my API is back up, then we see now that besides book ID, title, description, etc., we now have a publisher element. We see that the schema did not break because we didn't change anything existing. We added something to it. And we see now that each book had a correct publisher. So in this case, for the producer, both tests passed. We did not introduce any breaking changes to our customers. And we successfully added a new element or a new attribute to the API. If this all works, obviously before this, but then the producer of data should talk to the consumers and tell them that there's a new attribute available so they can work with it in their application. So that's that about the producer-driven contract testing. Now, what are the pros? Producers in control. It's only one team or one party that's in control, so it ensures it reflects the API's capabilities and constraints. It is backwards compatible, so if they want, they can add fields that are new and do not change anything. But if they do introduce a break and change, then it's possible to update the version so they have a v2 for the new change, which consumers can also implement. This as well as automatable in CI/CD pipelines. And most important of all, it promotes collaboration because the producer has to explain to the consumer what they will deliver, and the consumer has to determine whether or not they can work with that or they need something else and ask the producer for changes. The downsides are that there's limited consumer input, so it might lead to unmet needs by consumers. I just talked about updating the version, which sounds nice, but you don't want to have 100 versions of one API running at the same time. So it's difficult to maintain them. And at some point, the older consumers with the old version have to move over to the new one. And there's a heavy producer responsibility on anticipating and testing the consumer use cases, and that can also be challenging. Next one is consumer-driven contract testing. Again, we have the bookstore providing a list of books, and we have the bookstore app receiving a list of books. There is a contract involved, but in this case, it's the consumer who drives the creation and development of this contract. So again, it's not that the consumer says what the producer has to do, but it's the consumer who initiates the contract and has to ask the producer to deliver if they can. What's different here is that in the previous example, the producer would have one contract for multiple consumers, but with consumer-driven contract testing, each consumer can have their own needs and therefore also their own contract. And the producer, if possible, has to adhere to all of them. For consumer-driven, there's, of course, structural contracts, because each consumer can have their own structure that they expect. Little example here that we've seen a lot of times before, but mind the required bit. Here we require the book ID, title, and score, but maybe another consumer requires the book ID and the author. So summing up this one and this one, the producer has to always return book ID, title, score, and author to adhere to both these contracts at the same time using one version. Besides that, consumer-driven contracts can also be behavioral contracts. So for example, one consumer says, if the bookstore contains books, when I request the list of available books, the response book objects are sorted by book ID ascending. So that's from low number to high number. But another consumer says, yeah, that's all nice, but if they contain publisher information, I want to be able to request books from a specific publisher with an extra parameter behind the API. And then this response should only include books from this specified publisher. So we'll look into Postman because there's a little icon on the bottom right. But we see here two behavioral contracts. So one of them wants the books to be sorted by book ID and from low number to high number. And the other one wants an extra parameter. And after that, the response should only include books from that specified publisher. So let's see if we can get that to work. Just open Postman. So first of all, we look at the contract over here for the consumer-driven contract testing. Okay, so I said that we would also need the author here because one consumer requested these three and the other requested the author. So we'll just edit this schema to also include the author in the expected response. So every time we receive a book object, we also require to have an author in it. So if you click send now, then we see that our schema validation passes because we always send the author element. But this one, this consumer requested sorting, right? So here, if we get the list of books, I retrieve the IDs, I sort them, and I check if the actual IDs match the sorted IDs. Again, don't want to make it too technical, but if I click send now, and we kind of already know this because we've seen this before, we see that this test fails because we see that the actual numbers are 239, 670, 11, 678, 502. That's not sorted. These are. So the producer in this case, to adhere to this consumer contract, has to make a change where the numbers are like this and don't start with 239. So the publisher did their work, the producer, and they actually created the change. So if we click send again now, then we see that the books come in the correct order. And we also see that our producer-based or our consumer-based contract test is passed because the books are now both sorted and they still match the schema. So that's all nice, but there was another consumer, remember? And they asked something really funny. They asked for an extra query parameter. So in this case, the consumer here expects the result to adhere to the schema, but they also expect to get, because we use test data, only one book back if they use the query parameter, because there's only one with the publisher 42 test cases limited. And they also expected to have the correct publisher, namely the one that we have defined over here. So here we have the books API with the extra publisher parameter, 42 test cases limited. If we click send here and already updated the API, then we see that we actually get only 42. Everyone still here? There's something weird going on. Okay. No? Is everyone still here? Looks like I'm not sharing my screen anymore. Something weird was going. Okay, I see lots of thumbs. Just going to try and share my screen again. I don't know what happened. Okay, sorry about that. Some technical difficulties. Did everyone get the last test, or did I?
You can just repeat it. You're audible and your screen is also visible, Wessel.
Perfect. Yeah,
Okay.
sorry, I don't know where I got cut off, but something with the internet maybe. I'll
Not a
explain
problem.
again. So in this case, we have this new query parameter behind the /books API. So we're now looking for a specific publisher, like the customer requested. In this case, 42 test cases limited. So we expect to get only one book in return, and we expect that the actual publisher is the one we defined here. So you already see that they passed, but I click send again. So in our body, we see that we actually got the one. We see that the publisher is also correct based on our test. So in this case, the producer created 2 test cases and now adheres to both of these functionalities. So both the sorting passed and the query parameter passed. So that was the example of consumer-based contact testing with example in Postman. Back to the presentation. So the positives are that it's consumer-centric, which means that it ensures that the API meets the needs of specific needs of customers. There's a flexible integration because it allows customers to test independently instead of having this big contract from the producer. It can prevent breakages, as do the other ones, but in this case, the consumers have more control on them. It's automatable in CI/CD, and what I think is most important of all, it really promotes collaboration. So the consumers really get to talk to the producer and discuss with them what's possible and what's not. The bad or the difficult, it's a lot more complex than often producer-driven contract testing is. There may be versioning issues, as I said before, especially with when you have 100 customers with their own contracts. It can be really difficult to keep track of them and can be maybe even almost impossible to adhere to all their contracts and their needs. And there's a big consumer dependency. So the collaboration I find really positive because I like to communicate, but it can also be really confusing or difficult if the consumers are not going to the producer with their needs. So it requires really active participation. This is just a small slide with some differences between PDC and CDC. It's more for afterwards, so you can take a screenshot of it or see it back in the video. As I want to move on to my next point, which is mock testing. I know that mock testing is more a form of integration testing, but it has a really big link for me with contract testing, so that's why I put it in my presentation. So let's go. So traditional integration testing, as I said before, you need a shared environment. Everyone has to be finished with what they're doing, and there's a really heavy load on the testing there. While with contract testing, People can test against contracts or have the contracts as a kind of support for the testing and for what they have to develop. But mock testing can really help in this at a certain point, because what's a mock? Say we have serverless application with a lot of logic in it. It may be really big. It may have several APIs that it supports and has to maintain. While a mock or a stub is a lot smaller, it only contains partial logic. Sometimes it's just to get the response that you expect with static data can really help build your application, because you can anticipate what's coming, what kind of data is coming to you. And why I find I have to talk about it here is because those mocks can really nicely be based on a contract. So example, yeah, so this is contracts. We don't test against contracts, but again, mock here. The example, say we have this bookstore and we have the app, and maybe they want to implement that people can buy books from this bookstore. Then this app has to have a link with some kind of payment service, because people have to pay for their books. And in this case, the producer can be some kind of payment platform. I don't know if it could be a bank, whatever. I don't work for payment platforms, but it could be a lot of logic from the producer, and it can take a lot of time before they can actually get started on working on this for our little bookstore app. So what can we do then? We can talk to them about what we need them to deliver, see if they actually can, write up a small contract, and mock the response that we get. So in this case, we would be using the partial logic, and it could look something like this. So really simple. I create a schema together with the payment party, and I tell them, okay, when I call your payment service, I need to get a status back with, it could be a success, could be a fail, whatever. We can talk about this, and we should have a transaction ID so I can process it further in my app if I need to. So on the right, you see the code or the expected response, which is not a big one, but it may be really important. And the good thing is we should be able to get started with it right away. So moving quickly to Postman. In this case, I need a mock. So I start a mock server. And here I tell them that I want the mock server to be called payments. So it's not the /books, but in this case, it will be the /payments. Whenever we call this, we want to return 200, and I always want to have the status and the transaction ID. I'm sorry, but I could not make this tiny screen bigger, but it's the same as I showed on my slide, a JSON object with the status and the transaction ID. So I call this mock server the payment service, because it's about payment, and I tell Postman to create it. Now, this is where they are hosting my new service. So I'm going to use this to show you guys what happens now. I create a new request. I create a new request, which I am able to do. It is in this case, I think I kind of messed up here because I think it should be a post request, and I did it too quickly. Now it's a get request, but you guys get what I'm getting at. I created something that's called payments. Postman created a mock for me over here. And if I press send here, I should get back the status and the transaction ID. So again, it should have been a post because my app is sending something to them. But anyway, it's demo purposes. This just shows that you can really quickly create a mock service, even in a tool like Postman. Takes a couple of seconds. But if you want to act on this, then you can actually use this to create your app or continue building your product without needing the actual product from the payment service. Back to the presentation. I see I have about 10 minutes left, so I'll be really quick. Mock testing allows for independent development because you can run it locally and act like you are dealing with a real service. It's automatable in CI/CD, and it can focus on edge cases. So you can tell it to give you something back that you would really have difficulties to get back in an actual scenario. However, it's not a full substitute. There's a lot of maintenance overhead, especially if things change. And about that, there's limited scope. The biggest deal here is if the API changes over time, then you have to update the mock. And that's not something everyone does. So it can lead to false positives, whatnot. Lastly, I want to touch end-to-end testing shortly, because I don't contract test on an end-to-end basis yet. I know it's possible, but it's not my expertise. But like I said before, in the past, we would get a lot of big, heavy testing on integration environments, and that could result in a lot of bugs because we hadn't thought about it in the previous steps. And with contract testing in place, or at least part of it in place, we are at least thinking about and documenting what we need and what they can deliver in an earlier stage, which should lead to less problems later on. So shortly, the good and bad about contract testing in general. There's CI/CD integration possibility, very early error detection. It could be that you find an error just by talking about creating a contract. It's easy to scale for the scalability, because each type of contract testing can scale with the application, and they can support multiple teams, services, and consumers. And importantly, it encourages collaboration between producing and consuming parties. The difficulties: there's some upfront investment, setting up the contracts, writing the tests, integrating them into CI/CD, but it can really speed up the process later on. As I talked about before, maintenance, versioning, etc., can be something that's challenging to achieve, especially in large environments. And positive and difficulty, it requires collaboration. So everyone has to be willing to collaborate on this. Briefly, the key takeaways. I've talked about the importance of contract. Schema validation is kind of foundation, but definitely not covering everything because it's only the structure and the data types we check. Choosing between PDC and CDC. Please look at the one slide with the overview that I showed earlier. Mock testing can be used for flexibility and independent development. We are sure to catch issues early. And importantly, collaborative testing is key. Now I have one slide with a one-liner because I like one-liners to end with. Contract testing is not just about preventing issues, it's about encouraging communication within a complex API landscape. And I really mean that. The most important things for me with contract testing has been the communication. And I personally learned so much of how the APIs were built and what we could and what we could not do. But also talking about contracts also really helps with documentation. So finding a lack of documentation, finding that is outdated. Yeah, communication is key, at least. Thanks. Are there any questions?
Yes, thank you so much, Wessel, for this amazing session. There's so many Q&As. Let me just pick some of for you here.
Yeah, will they come up on the screen or should I stop sharing?
Yes, I'll do that. So the question is, contract testing and different in each layer we test and use different framework. Can you please suggest any tool for the same?
Yeah, so I think I understand the question. So we have different layers to test in, probably referring to the test pyramid or something similar, and whether or not we use the same tools or frameworks in the different test layers. Well, for me, contract testing, as all automation types, should be tool agnostic. So I would not suggest one tool that to rule them all in a way. I just showed everything that it's possible in Postman. It may not be the most efficient tool if you have a lot of different contracts to test. I know, for example, that Pact is a really powerful tool for consumer-driven contract testing. But yeah, I would not recommend just one tool. I would probably first see what tools you use at the moment, and if you can make a head start in that. And if you think that it feels right, the contract testing, and it delivers value, and you get other people in your project to get the same idea, then I definitely look into more tools that can do more than Postman can, in a way.
Thank you.
Hope that answers the question.
Thank you, Wessel. Let's move on to the next question. So, are there any tools or best practices that can improve contract testing, mitigate the negatives and factor of the positives?
Tools or best practices. So I speak from personal experience that I find the best practice is to communicate. And I know it may sound really simple, but there's no tool that can beat collaboration and proactive collaboration between parties. So if your team is consuming an API from a producer and you need something new, then you really have to sit with them and see if it's possible, the things you want, if they can actually deliver the data, that you need any workarounds. Same for a producer. If they want to introduce something new, but they might break something, then they really have to go to the consumers, talk to the consumers, see if the consumers want to change their code to, to fix this breaking change in a way, or that they need to up the version, or that they should not introduce a change in any form or way. Yeah, so I don't know of any tools that can improve contract testing, other than the ones that help you do your work, but there's no specific one that I can think of.
Thank you, Wessel. So here's the next question. In what all the layers of an application we can apply contract testing?
Yeah, so that's I think that's a nice question. There's I think everywhere where there's an interaction with another system, you can apply contract testing. So I now talked about APIs, which is obviously pretty easy because a lot of people work with APIs and it's kind of tangible. I could show it in Postman. But for example, a database connection, writing SQL and expecting certain data formats back, that's a way of contract testing. If you work with Kafka or something else that is asynchronous, then you would have a different type of contract testing. So yeah, actually any layer where there's an interaction between systems, you could apply contract testing. I just used APIs as an example.
Okay, thank you. Let's move on to another question. Can you tell some of the good use cases where we should go for the contract testing?
Well, yeah, so if you have an interaction with another system, yeah, it's a bit too simple. Yeah, for me, contract testing works with any interaction, but I can understand that if you have just this one simple API that never changes, that you might not see it, that you see the good use of investing so much time into something like this. But yeah, I'd say, Pankaj, if you would like to talk about it afterwards, I'd like to just talk to you personally about this, because it really depends on your situation. And from your question, it kind of tells me that you're in doubt whether it would work for your situation or not. So hit me up on LinkedIn or wherever, and we can talk about it.
Sure. So let's move on to the last question.
Sure.
Should a contract test focus on the specific current usage from a consumer or a list, all that is currently available, such as from the open API spec?
Not 100% sure I understand the question, so I'll try to reformulate it the way I think I should answer on it. So the question is whether the contractor should focus on one specific consumer, or it should focus on the API as an entirety. That's how I see it. So in consumer-based contract testing, it's the consumers that drive the contracts. It's the consumers that suggest the contract to the producer. And then the producer can say whether or not they agree with the contract, or maybe they cannot deliver whatever the consumer wants. So the consumer's test cases are based on that consumer specific situation, but it's the producer who is in charge or has responsibility to make sure that the API adheres to all those contracts. So in the end, each consumer will probably test whether or not the API adheres to their contract bit, but the producer has to test all the contracts of all the consumers. So I hope that answers the question.
Yes. So thank you so much, Wessel, for giving your time and sharing amazing insights over the topic. Once again, thank you all the attendees for joining the session. Wishing you all a good day ahead. Thank you. Bye-bye. Thank you, Wessel. Bye.